And David, maybe you can start. And I mean, he's an awesome developer. He needs no introduction. So he works at Influx Data, and he he does some awesome stuff around Golang, around Influx Data, time series, and all that. Even Kubernetes. So he does a lot of good stuff around Kubernetes. So I thought this would be the perfect session for everyone in the community to learn how to set up actually a production ready monitoring setup, which is very much required. So he'll be going from the basics to the advanced level, and let's hear it out from David. David, over to you.
Hey, thank you very much. So, I mean, that's already a wonderful introduction. Um, I'm not going to add anything to that other than say I'm in Scotland. I've been working with Influx Data now for 18 months, and I am hoping today is going to go rather well.
So I'll
So I
stop the
will.
share and I'll allow multiple participants to attend. And here you go.
Yeah, that's perfect. Thank you very much. All right. Okay, so I've kind of put together a rough plan of what I want to cover. We're going to start off with a fresh cluster. I am using kind, and I have just spun this up momentarily. We have nothing running, so we're going to go from 0 to monitoring Kubernetes in probably somewhere between 20 to 30 minutes, depending on the time we have left at the end, and depending on what questions you wish to ask. Feel free to poke and prod, tell me what you want me to focus on. I will pick up some of these more advanced ones towards the end. And of course, if we make really, really good time, then we'll try and get through all of it. But to start, what we want to do is take our brand new Kubernetes cluster, and we want to deploy influxdb 2. For that, I am going to be using our Helm charts, which I've been maintaining now for around, I don't know, 4 or 5 months. We have a chart for influxdb 2. We don't recommend you run it in production just yet, but it is getting very, very, very close. Once we have influxdb running inside of our cluster, we're going to take a look at a couple of the opinionated ways in which we encourage you and suggest that you run Telegraph to scrape all of the metrics. Now, when I talk about monitoring Kubernetes, I generally like to break that down into 3 different components, and we'll cover them as we go as well. But unlike all, or very much like all production systems, we have to deal with the underlying host first, right? Kubernetes is no different. We have to understand the machines, the VMs, the bare metal, whatever is running, whatever the control plane and the cluster is running on. We have to understand that, monitor it, and automate it. And the Telegraph daemon set deployment chart is the best way to do that. Once you've got that covered, you then have to talk about the surface layer, so the applications themselves that run on top of Kubernetes. And we're going to look at how we can use Telegraph in order to scrape the metrics from applications that expose Prometheus metrics within the cluster and applications that don't. And then there's a little bit of layer in the middle. This is the third part of monitoring a Kubernetes experience, and that's the control loop or the reconciliation loop. And that's understanding, we've got the underlying bare metal, we have the surface layer, but what is Kubernetes itself doing? So we have to understand, are pods not scheduling? Why are they not scheduling? Are we missing secrets? Are we missing config maps, etc.? So we'll try and dig into a little bit of what metrics are available to make sure that we have that covered as well. Moving on from there, we're going to take a look at Packager, which is a brand new component for influxdb 2, which allows you to deploy pre-configured dashboards, Telegraph configurations, and buckets, along with a few other bits and pieces, that give you an out-of-the-box experience that we feel is unrivaled. So we'll take a look at just a few of those templates that are available and how we connect them all together. Then the final 2 segments are slightly more advanced, but they offer up a lot of flexibility and power with the way that we configure all of the other components. So the bit in the bottom, the BYOT, is a project I've been working on called Bring Your Own Telegraph. And it's a way to build a Docker image with Telegraph in it with a very specific compilation step unique to your configuration. The benefits of this are the image size is reduced by a large factor, and the runtime characteristics, the memory and the CPU, are actually about 1/3 of what they are running the standard Telegraph image. So we'll look at how we build those images and how we consume them in Kubernetes. And then we have Telegraph sidecars and the operator, another project coming out of Influx Data. We actually have a working group internally called Sig Kubernetes. There are about 5 or 6 of us that are really passionate and driven and making our experience on Kubernetes the best it can be. And these projects are coming out of that. So the Telegraph operator is a way where you can do automatic sidecar injection of a Telegraph container into a pod to scrape metrics for applications that you don't necessarily have control over. When you use Helm charts, not all of the charts will provide a means for you to add a sidecar. So this makes it nice and trivial. Okay. So step 1, we have a Kubernetes cluster. Let me make that bigger. Yep. And we have influxdb. Let me make this bigger. So what we can see here is I have a make file. I'm a huge fan of make files. I do everything as a make target. But what we want to do is deploy influxdb to it. Now, I am not providing anything special here. This is a straight up Helm upgrade command pointing at my influxdb chart within the influx data repository. I'm not even providing any overrides, any configuration at all. If we take a look at the chart, we do have the values file. You are welcome to override bits and pieces of it, but by default, you're going to get everything that you need. The admin user is going to be on an organization called Influx Data, a default bucket, and the username will be admin. And the password is generated for you and stored inside of a secret. So if I come here and I say deploy influxdb, now what's happening is it has applied the chart already. And if we run a watch, we'll actually see all those pieces starting to come out together. Now, because we use a post install hook to deploy the user and configure the password and a token, this just takes a little bit of time because it's waiting for that to finally succeed. In order for that to succeed, we have to pull the influxdb2 image, spin it up, wait for the API to be healthy, and then the create user will work. And that's what we see here, running complete and complete. So now when I run get pods, we'll see that we have one instance of influxdb2 running inside of our cluster. If I run get secrets, we will see that we have this secret created for us by the Helm chart. So let's take a look at that. Whoa, wrong link. There we go. I'm just going to use output negotiation here, request this in JSON, just so I can pipe it through JQ. So it's a little bit easier to consume. And what we see is we have a randomly generated password and we have a randomly generated token. And we will need both of those as we add more features to our cluster. But what I want to do first is just show you this working. So we're going to base the code our secret. Remember, it helps if I base the code it. And we will copy our password. Now, in order to browse to this, we just have to do a quick port forward. We can fire open my browser and we'll just hide my notes. And we can remember the username was admin and we have a password. Now, this is a very vanilla, generic, empty, pick your own adjective influxdb2 instance. When it comes to data, we do see that we have our default bucket, but we have no filters, no tags, no measurements, no nothing. We have no dashboards, we have no tasks, we have no alerts. And it's okay if you don't know what all of these different components are of influxdb2. Feel free, if you have any curiosities about any particular feature, to drop that in chat and we'll try and cover that in just a little bit. Okay, so let's try and get some data inside of influxdb. Now, to do that, we're going to start off covering the first layer, which is the bare metal of the virtualization, the VMs, the cloud, wherever you're running your cluster. And to do that, we provide a very opinionated chart that doesn't actually take too much configuration. Now, we do get a lot of requests from people that ask us to add plugins to this. It's very unlikely we're going to accept them because this does one very specific job. And I really want to show you that it does that well, and then show you how you can use the other telegraph chart to do any specific configuration that you want to do. Okay, so we are going to just close our port forward. And we will see here, our deploy telegraph DS, we are passing in a file values override. So let's take a look at what we're doing. So, excuse me. So I've tried not to override too much. Again, it's opinionated. The only thing we really need to do here is tell it where our influxdb instance is, or in fact, we can configure any outputs that we want, but I am using influxdb2. I need to pass in my token. Now I'm hard coding this for today. It's not what I would suggest, but you don't want to see me wasting time configuring secrets. So I will run my JQ again, and we will decode our token. So this token is generated again for us by the chart. And I'll probably have to copy this at least 6 times in the next 20 minutes. Okay, so we drop in our token. I'm going to remove this. This is part of the BYO stuff that we will look at later. So let's copy that in. The only option I'm actually using in this chart, besides telling it that I want to write to influxdb2, is that I also want this telegraph to monitor itself. Telegraph has a really good plugin called Internal that exposes all of the metrics about how Telegraph is performing. And there are 2 very, very important measurements that we need to track to understand the health of Telegraph. And we'll take a look at them as well. Okay. So we're going to deploy Telegraph DS. Okay, and then we run get pods. We'll run that on a watch. We'll give that less than I can even speak. It's now running. Okay, so this in theory should be writing data to our influxdb instance. The Docker plugin is okay. I'm using kind for my Kubernetes cluster today. If I was using Minikube, we would actually get Docker metrics, but we can ignore that for the time being. But what I was looking for here was to see, do we have any error messages that say that it cannot write to influxdb2? And that is not the case. So I think everything is working as expected. So we will close that, clear that, and run our port forward once more. And if I come back over here, oh, don't make me log in again. Good. Don't want to have to keep copying that password. If we come to our Explorer view, we can already see a very different panel here. We have all of these metrics that are being consumed for us by the Telegraph daemon set deployment. Now, just to reiterate the fact, Telegraph DS is for the underlying machines, bare metal, or clouds, which means we're going to want to understand how our CPU is affected by the workloads that we're running on it. And if I just drop this down to 5 minutes, we can actually track the CPU usage information on a 10-second interval over the last couple of minutes that Telegraph has been running. As well as that, we have access to disk information. So we can track the free, total used percent. We hit submit, and we have more metrics. Now, we're not really running any workloads on our cluster right now. So if any of this changed, I would be a little bit worried. So I do expect this to stay relatively flat. Now, we also enabled the internal option on this Telegraph. So what we want to understand is what 2 metrics are really, really important. So if we take a look at our buffer size, our buffer limit, and we'll track our metrics written. What we're going to expect to see here is that our buffer size and limit should be relatively flat because we're not actually using them too much. Our metrics written should be on a linear growth as it writes the same amount of metrics every 10 seconds. There we go. So our buffer size, our buffer limit, relatively flat because we're not relying on it. Now, if I go and shut down influxdb2, we will see a spike in the buffer size increasing towards the limit. The metrics written will drop off the cliff, and then we can spin influxdb2 back together again, and all of this will return to normal. So it's really important. especially with some of the more advanced concepts that I'm going to speak about today, to understand when a telegraph is healthy and how to spot that. So we have our linear growth, we have our flat lines for the buffer. Let's go cause some damage. Now, what's the best way for me to make this to fail? I'm going to cheat and I'm going to edit the stateful set. Because I could delete the pod, but Kubernetes being Kubernetes is going to restart the pod, and I really want to show off the buffer size thing climbing rather quickly. So we're going to come down to here. And this is my favorite trick in the whole 4 years I've been using Kubernetes, is to add command sleep and sleep for 50,000 seconds. It is the greatest thing you can do with any pod. So our pod should be restarting just now. Terminating. Running. Now, it's never going to get ready. There are liveness probes on it. It may still get restarted a few times, but it should never get healthy. So let's talk about these telegraph configuration options where we allow that data to build up. Now, we're not overriding anything specific with regards to the buffer size or the buffer limit in our telegraph configuration, but I just want to show you what those options are. Configuration. There we go. So on the agent section of the config, we have the ability to set our batch size, which is really important depending on the scale at which you're collecting metrics. But then this metric buffer limit, which is the one we're talking about right now. And this is a in-memory cache size that says, I will store this many measurements or metrics or points, whatever you want to call them, in memory in the event that I cannot write to any of the outputs. So if we edit this again, oh, I'm not in BIM. Oh, there we go. Let's get this healthy once more. Oh. What did I do? I had a syntax error. Let's try again. Ah, yeah, because here we go. Okay, so run pods, influxdb is going to go to happy in just a moment. Yes, you are. Yes, you are. Don't lie to me. Let's just take a look. So our readiness probe is failing. Our command is still sleep, so that edit did not take place. Let's just pop that open again. We don't have a command. Okay, so this is just a bug that sometimes happens where the spec changes and it doesn't remove the pod because it's unhealthy. What we can do is just delete that to encourage it to restart. The command and arguments will not be overwritten and our container will become healthy again. What I want to see is port forward and back to influxdb2. We're going to see a burst of telegraph metrics go from the cache to influxdb2. And I've actually had this not working for a little bit longer than expected. So we'll probably see that we hit the limit on the cache and we will have some blank spaces on our graph, but that's okay. And I'm assuming that the sleep command also does not respect POSIX signals, which is why we now have to wait the full 30 seconds or slightly longer for the sig kill to be sent. I'm an impatient person, so we'll do force, grace period, 0. That is the RM minus RF of the Kubernetes pod landscape. We now have influxdb running. It's going to go healthy. I'm not going to keep checking it because I'm pretty confident. Cool, awesome. And of course, I really do need to get my password back. So, okay, get secrets. and echo, and we want UV, this one. All right, so let's look at our internal metrics. All right, what do we have? Okay, so we didn't consume too much of our limit. We can see our buffer limit is still very high here. We can see the purple line coming across. So there were no more written metrics. This flattened out from the linear growth. In fact, if we view this over, yep. We grew to here. This is when we shut it down. And what we can see here is that when we stop rising on our linear growth and the metric written, is that our metric buffer size is increasing until the moment the influxdb2 becomes healthy again, in which case we write a big flurry of metrics, our buffer size drops, and we're back to normal operation. So when it comes to deploying Telegraph at scale inside of a Kubernetes cluster, you really want to enable internal metrics, and you really want to alert whenever your buffer size gets too close to your buffer limit, and just make sure that everything is happy and you never drop metrics. Dropping metrics is generally not what we want. Okay. Now, we have a whole bunch of other metrics here. We have access to the system, the swap, the number of processes, network, memory, CPU, all of those kind of bare metal, cloud, Linux host, kernel stuff. We also have access to a few Kubernetes components, which are being scraped for us too. So we have node statistics. If we want to track the file system, we've got that here. We can track pods, which allows us to see how much CPU is being consumed by each of our pods. We can actually see each of the pods there. But we don't have anything dashboard-wise that allows us to really understand the nodes within our Kubernetes cluster. So there was a tool that I said I would show us called Packager. What Packager allows us to do is to leverage the community-driven templates initiative from influxdata to deploy dashboards that people have already built for us. Now, the one I'm curious about is here. It's called the Linux System Dashboard, which is going to give us information on uptime, CPU, and just a nice glance and overview of all of the machines that are part of our cluster. Now, of course, this is a contrived example. I am using kind. We're only going to have one node, but we still get enough metrics and enough dashboarding to understand what is going on. So we can just copy this command, and this should fail. Good. Okay, so we need to configure a couple of things. First, we need to provide the organization name. Mine was influxdata. We also need to provide a bucket, of which mine was called default. I think that goes, not a global one, so I think it was here. Excuse me. What else do we need? And we need an influx token. No, we can do this token. Sorry, I'm going a little crazy on my tabs, but I just need to basically code this again. And drop my token here. Now, I think that might be all I need. Well, maybe we don't need bucket after all. Yeah, we provide the bucket and the template, so it's okay. Ta-da. Now, because I've got my text zoomed in, we're not going to see this particularly well. In fact, why don't I just copy this? Again, there we go. What we get is a preview from Packager that says, these are all of the resources that I'm going to deploy to your influxdb instance. We're going to take a leap of faith. We're just going to say, we trust you. Please go away and make my cluster a little bit more awesome. Now, if we come over to here, we refresh. We have our Linux system dashboard already pre-configured for us. Now we can filter by the host. This is only one because of my setup. And we can filter on the bucket. The only one we particularly care about right now is the default bucket. And right away, I have a really good visual representation of the machine that is a part of my Kubernetes cluster. I can see the CPU usage is a little high, but that's okay. It's because it's my laptop and there's lots going on. We can see the disk usage is more than fine. We can track the disk I/O. This little burst of activity here would probably be pulling down one of the images, as well as the Telegraph logs. So when Telegraph is failing to write to influxdb when I broke it, there would have been a lot more flurry of activity on logs. Disk I/O is a really good way to identify problems. We have our network traffic, all pretty standard at this point. So using the influxdb2 Helm chart, the Telegraph DS, and a community template with the packager command immediately gets us around 30% through where we need to be for a complete Kubernetes monitoring experience. So I'm just going to take 10 seconds to grab a quick drink, and if there are any questions from anyone, I'd be happy to answer them before I move on.
Yes, there are a couple of questions. I'll read them for you. Let me go from here. Okay, that will be covered later. So okay, where is all the logs saved for influxdb?
So we're using the default login driver on Kubernetes, which is a file and var-lib containers on the nodes themselves. So the logs are not being consumed by anything special at this point in time. However, if we want to see log examples, I have prepared one where we use fluentd to collect all the logs and write them to influxdb as well. So we can show that off if that's something people want to see.
Cool. And okay, so people want all the links that we have shared to be shared. That is another one. And what is the configuration of the dashboard? Where is the configuration of the dashboard stored if you want to customize some parameters?
Yeah, great question. So you can fork this repository or just download the YAML. So if you go to influxdata/community templates, this is just a YAML representation of everything needed to build that dashboard. You can change the colors, the labels, the buckets, the queries themselves. You can change anything. What's also really good, and I haven't really shown it, but we can see it here, is that these dashboards also provide telegraphed configurations to collect those metrics. So if you come into data and go to Telegraph, we have a Linux system template for collecting that data. We can click on it and copy that entire configuration, or we can specify the URL and have Telegraph download it for us from our cluster. So there's a lot going on there. The best thing to do would be to check out the templates, the community templates repository. There's documentation, there's loads of examples, and it's growing at a really fast rate with new stuff being added all the time.
Yeah, it's really cool, the templates. I mean, so easily you can have such an awesome dashboard, and it's built by the community for the community. So that's really good. And by the way, if anybody doesn't know, there is a inventors program going on by Influx. So if you contribute to one of the templates, to one of the stuff that you are using, so you will be part of the inventors program by Influx.
Yes, the final link I'll give you just now as well, because everything I'm doing, everything here is already published online. So there is raw code /influxdb examples on gitlab.com. There's a Kubernetes folder, which provides a complete out-of-the-box horizontal pod autoscaling, GitOps monitoring, Kubernetes monitoring. Everything that I'm going to cover today is also in here. And this repository itself is called Kubernetes Fire, which is also in my GitLab. And that's just my attempt to do something a little bit different with regards to the way that we monitor Kubernetes. Still very much a work in progress, but we'll cover some of that as well today.
There's a follow-up question. Does it offer possibility to correlate failure of logs across k8s resources on the dashboard?
So the story there is not where I want it to be. Definitely a great use case. The way that we consume on the dashboard side is we can add a table cell below here, which will show the log data for the same time period as the dashboard. So you can view the log data next to the cells. We are making we're making much better improvements to that will come out over the next 3 and 6 months, where we'll have a proper purpose-built log viewer and ability to filter the logs. But unfortunately, that's not great right now. But we will take a look at that with the Fluentd example, and you'll see what I mean. You'll see my frustrations, and you'll see why I want to make it better.
Okay, cool. And one more we have before we move to the next segment. You can take this later as well. So this is something in comparison to Influx. So probably it's, can you give some comparison with similar products like Prometheus?
I guess so. InfluxDB and Prometheus are very similar, right? Prometheus kind of changed the game in the way that we monitor certain components of our stack, particularly the surface layer or the user application layer, or the service layer, whatever you want to call that. And that they flipped ahead and said that we're going to use a pull method instead of a push method. And that works really well within Kubernetes. And actually, what we're going to do with Telegraph and InfluxDB is consume Prometheus metrics from applications that expose them. Where InfluxDB, I think, then gets a little bit more advanced is that InfluxDB can store non-regular time series or event-based data, which Prometheus cannot. Which means that we actually have raw data instead of aggregated access to some things, which is very, very useful. And we'll try and do a demo or an example of that once we get a few more bits and pieces into the cluster.
Cool.
Okay, so I will continue for now, but those are really good questions. Please keep them coming in. I'm happy to answer anything, and we'll try and get through a little bit more content. So next up, what we want to do is deploy a telegraph that actually allows us to discover new endpoints and be a lot more configurable than this opinionated one that we drop in for you. So if we go back to my wonderful makefile, we will see we have Telegraph Kubernetes. Again, I'm using the Influx data repository. This time we're using the Telegraph chart, not Telegraph DS, and we have our own configuration where we wish to override a couple of values. Now, we don't need to use this. This is the BYO stuff we'll cover. Now, because we're going to, because this Telegraph operates on the surface layer, the service layer, we do need RBAC permissions to be able to speak to the API server and understand the workloads running on the system. So we have to create the RBAC policies. Right now, I'm going to go cluster-wide just so I can monitor every namespace. More advanced or larger clusters will want to disable cluster-wide and deploy a telegraph per namespace, potentially. And for the really larger clusters, or just the people that have a very opinionated way on the way they collect their metrics, may want to adopt a sidecar pattern, which we're also going to cover. We have to configure our outputs again. So let me copy this token. And please do not put your tokens in the values.yaml. I'm just doing that for quickness. And we are adding one extra plugin to this, where we're saying we want to use the kube inventory plugin to understand a little bit more information about our Kubernetes workloads. So let's deploy Telegraph. Kubernetes. There we go. And if we run get pods, I'll just make that a little bit bigger. And this is now running. So what do we want to see here? So we didn't highlight all of the Kubernetes metrics or measurements that we had earlier, but hopefully the eagle-eyed amongst you have noticed that we have a few extra ones popping up. Now, the first Kubernetes one that we had on this list before deploying this was Kubernetes node. Now the first one is daemon set and deployment. So what we can actually see is we can track that little bit in the middle there as well about whether we have everything that we need from the reconciliation loop. If I just stick this on a 5-second review, we can actually see the point where containers are requested and then containers are fulfilled. So we have replicas unavailable 0 here, and we have replicas available 1. That's good. What else do we have? We have information on endpoints, which allows us to understand the services within our cluster. We have our persistent volume information as well, which is vitally important. And we have the pod volumes. They're each slightly a bit different, but they're both very important when it comes to understanding the PVCs and understanding whether they're almost full as well. We have the ability to look at the pod containers. I think we looked at that in the last plugin. So let's kind of move down a bit. And we have the service stuff here as well. So we're now consuming a lot more information about Kubernetes. But what about applications on top of the cluster? So let's deploy something a little bit more interesting. Let's deploy Nginx. Did I add a target for that? No. Shame on me. Okay. So our Nginx is running. Almost running. Just downloading the image. Cool, that is now running. Now what we're going to see is that we have nothing scraping these metrics. There are no Nginx metrics within this cluster. And there was a question about Prometheus. So what would expose Prometheus metrics? I'm going to go off script a little bit now, which has never went wrong ever, right? So oh, come on, Helm Hub. Let's deploy console. That's the one. I'm pretty sure this exposes Prometheus metrics. I'm going to add that repository. I'm very quickly going to deploy it with no configuration, and we're going to see what happens. No. Oh. Okay, so that's console deploying to our cluster. Now, let's see what I get for making this up, but I'm going to make it awesome. Don't worry. All right, let's just give that 30 seconds. So what I want to show here is first we have Nginx. So how do we get the metrics out of Nginx? And how do we get them into influxdb? The second use case, based on the question I had 5 minutes ago, was about Prometheus. And I also want to show you that we can consume all of the Prometheus metrics within the cluster. Now, there are a couple of steps involved there, but it isn't too taxing, and this should be done in a few minutes. So we're just waiting on the console image being pulled. I'm going to jump inside of the console container. I'm going to curl import 9090 just to confirm we have those Prometheus metrics. And then we're going to modify the values for console deployment to add an annotation that can be scraped by our Telegraph instance. We're also going to use the Telegraph operator to inject the sidecar into Nginx to also fetch its metrics, which are not Prometheus formatted or available. Now, I know that sounds like quite a lot, but I'm hoping that as we walk through the process, you'll understand what's involved for getting metrics from those services. And I think actually what I'm hitting now is I do not have enough compute power for these two to spin up, but we should be okay provided these two get started. All right, so let's do Nginx first and give console a little bit of time to get healthy. So if we take a look at Nginx, we have configured Nginx to expose its status, which is only available on 127.0.0.1. So it's secure, and the only thing that can request it is anything that shares the same networking namespace, which means something has to be inside the pod. I cannot collect these metrics outside the pod, and that's really important to understand. So we're going to deploy the Telegraph operator. Before I do that, I also need Cert Manager. There we go. I'm running a lot in this cluster, this Purvy cluster. Let's see. So cert manager runs in its own namespace. It's almost running, which is perfect. So we're going to try deploying the telegraph operator again. Perfect. And that'll just take a few seconds, but this gives us the ability to tweak and inject containers into other things. So when we want to deploy this, we have to define something called a class. A class is a pre-configured bit of telegraph configuration that we inject into the operator and make it available to other telegraphs that want to consume it. So I'm going to copy our token again. We're using the same bucket and organization, the same influxdb, and we'll just update that configuration. And I'm going to delete the pod just to make sure it's happy. And if we take a look here on our Nginx configuration, we've added some annotations. Well, I did this before, much like Blue Peter. But these annotations are how we interact with the telegraph operator. So what I'm saying is that we want to enable a new input. So we use the inputs annotation. We want to enable the Telegraph Nginx plugin. And we're going to scrape metrics on localhost at the same URL we configured in the Nginx virtual host. We then apply the class, which has our output configuration that says all of the data we collect should be written to the Kubernetes class. Okay. So, moment of truth. We have telegraph operator running. We have Nginx running. Nginx has one container ready of one container. That means my sidecar has not been injected. That's okay. That just means that I deployed that before the operator was healthy within the cluster. So by forcing a delete now of Nginx, the pod will be rescheduled. The operator will detect the annotations. And already we can see that this pod has two containers, or it will have two containers once it's healthy. Perfect. Now, if I come over to our influxdb, and I just give that a little refresh. If I scroll down, if I wait nice and patiently, I'm hoping we'll see Nginx metrics. So now we can actually look at the number of requests, accepts, active, waiting. Waiting is the important one you want to monitor. And we now have those Nginx metrics being written to Telegraph through sidecar injection with the Telegraph operator. So it's a really good way of collecting metrics that normally wouldn't be available to you in this kind of setup, or at least in a containerized setup. On bare metal, that is really easy to do because you just run something else on the host and collect the metrics. But in a container landscape, things are a little bit more tricky. So the Telegraph operator makes that possible. Now, I don't think I'm having much luck with console. So I'm just going to remove it. If anyone can think of any application that is relatively easy to deploy that exposes Prometheus metrics, I will show you how to do that. Otherwise, I'm going to move on. So now that we've seen this Telegraph operator and the sidecars, I want to talk a little bit about BYOT. So let's take a look at the size of this image that we're running inside of our cluster. Oh, I can't because it's unkind. I think I have it locally anyway. So let's do a image ls grep for Telegraph. 1.14. We'll just pull that down very quickly. And there is an Alpine variant, which I'll also pull. Sorry, I think I've gone a little bit over time. Is that okay?
And yeah, that's not a problem. If things are interesting, then you can go on and on and on.
I'll just keep going until you kick me off. All right. So I keep typing PS, ls. Okay. So what we have here are the official Telegraph images that we ship on Docker Hub. So 114, which is a Debian-based variant, comes in at 251 meg, and our Alpine variant comes in at 86 or 87 meg. Now, while those are not massive, we want to be able to do a lot better. Now, if we see the Nginx sidecar pattern that we've already adopted, what if we want every pod to have a Telegraph sidecar? Right? We really want to make sure that the images are small because we're going to be pulling them and pushing them across all of the nodes within the cluster. So how do we do that? Well, fortunately, we put that away. If we come to bring your own Telegraph example, did I get that right? I did. Then I've already provided some tooling that allows us to provide or allows us to consume a base Docker file and build our very own special container image. Yeah, okay, we'll just build it. I won't run it. So these steps are the only thing that you really need to configure. What the first from statement does. So if you're not familiar with the Docker multi-stage builds, you can use multiple from statements. So you can pull in and build resources with different base layers, and then you get to a final base layer where you can pull things together. So I'm using on-build instructions on this layer to compile Telegraph. And then I want to inject my configuration and produce a very small image. So I'm just going to provide a Telegraph directory, and I'm going to put a very, very simple telegraph.conf inside of this. And this, I'm going to enable one plugin and one output. Output.file. I think this is the minimum configuration I need. And yep, I think I'm good. So from here, I can do an image build, and I'll call this my Telegraph version 1. What's wrong with that? My Docker file is not empty, is it? Save the file, silly. Okay, so that is, oh yeah. The other thing we have to pass in is a argument that tells it which version of Telegraph we want. So we can say build arg. I believe it is a version 1.14.4 is the latest. Let's do 1.14. That's much better. Okay, good. So that's going to, what happens in the base image is it clones down Telegraph from github.com. It injects or copies our configuration, which we see here. So it copies that Telegraph directory. And it actually just mounts that or copies it into /etc/telegraph. There are 2 bits of code that I provided that allow us to customize the build step for Telegraph. And what it actually does is it removes the dependencies for any plugin that are not needed by scanning your Telegraph configuration to work out which plugins you do need. It will then compile Telegraph and spit out a Docker image that we can throw around very lightly and cheaply. And if we remember from the start of the session, I said that the custom Telegraph builds without all of the plugins, if we remember that Telegraph has 250 plugins to date, if I only want to use 2, there are significant performance benefits as well by CPU usage, memory usage, etc. So this will just take a couple of minutes and it'll spit out an image and we'll take a look at the size. But I would expect this to be rather, rather small. Okay. I will deploy the FluentD log collection now so that we can quickly take a look at that. And I will try and be finished for 1/2 the hour. So if I type make, oh, do I not have a target? Let's double check. Deploy FluentD. Oh, and I have to build the image as well. Okay, so let's build FluentD and deploy FluentD. Actually, because I'm using kind, the fluentd example may not work because I can't reuse the build context from inside the cluster. I probably should have used Minikube. All right, let's not do fluentd. Sorry about that. Okay, our telegraph image has built, so let's take a look. There we go. Now, I kind of gave away the size because I had a pre-built one there from earlier, but you can see that by doing a custom build with the 2 plugins that we require, we got that size down to 21 meg. The smallest I've been able to get it down to is under 6. That code is not public yet, but it does strip out all the processors, aggregators, and a whole bunch of other stuff from Telegraph that you're not needing. But I'm not comfortable in the generation side and the compilation step yet to really allow people to use that. But BYOT is a great way to get really lightweight, very specific, fast Telegraph edge collectors for your cluster. Okay. I think that is mostly everything that I wanted to look at. So I will take any additional questions that we have.
Yeah, I think for sidecars, it becomes very important to have the less size of the images. And I think this bring your own telegraph image makes a lot of sense. And we'll be waiting for your 6 MB image as well.
Okay.
So we have a question. Does influxdb uses nginx as default ingress controller?
So because it's a database, we don't actually use an ingress controller because we don't generally want people to expose their database to the world. Now, of course, there are reasons that people may wish to do that, especially in secure environments with VPNs and such. You can use any ingress controller to expose your InfluxDB as long as you know what you're doing and you don't publish it on a big bad World Wide Web.
Okay. So if you have any other questions, folks on the call who are watching it live, please feel free to post any questions. David is here with us. And so we have seen the 3 types of telegraph deployments as well. I mean, it's as a deployment, as a daemon set, and as a sidecar as well. So, and you know the benefits of all 3, so which makes sense, like when to use which. And the sidecar is even more powerful because it gives you insight of the pods, which generally you don't get the metrics for. So you, depending on the things that you want to monitor or that you can do easily with telegraph. And yes, influx is there, and you have the power of templates, and you have seen the templates. There are already number of templates that are growing, and it's just as the telegraph plugins community, we have more than 250 plus, and I'm sure that the templates also will soon cross that number very easily, because people have built a lot of crazy dashboards and they have shared it with the community, and it's a lot of them are building in place. So that's, I feel that's really good, because you don't have to create anything. You just have to deploy stuff and use the templates and do that. I mean, it's very good. So I have one question, like if we have to deploy let's say the tech stack, or the influx 2 which already comes with all the 4 components, so how do we do that? So if you do not prefer the helm way as of now, because that's not production ready yet, so what would be the other methodology
For deploying InfluxDB1, did I hear the question correctly? Or just InfluxDB2, but not Helm?
Yeah, influxdb2 but not helm.
So you would, to be honest, I would say use the Helm chart. It's the best way to deploy InfluxDB2 to a Kubernetes cluster right now. I don't see us supporting any other approach yet. I have been speaking to Alex Ellis of OpenFaz.
Yeah.
He has a project called Arcade, which makes
Yes.
deploying things to Kubernetes child's play almost. Really, really cool project. And we're talking about how we can either expose the InfluxDB Helm charts to Arcade, or even provide our own JSON configurations for deploying that as well. So we do plan to maybe support 1 or 2 more max alternative deployment things for people that do wish to avoid Helm. But Helm is definitely the way to start today.
Okay. Are there any limitations apart from if we deploy using Helm and provide the proper configuration? So there are no limitations as such for a production ready setup, right?
No, as long as you have a cluster capable of giving you a pretty decent CSI implementation, a way to have storage that can be migrated across your cluster,
Right.
you're in really good shape to run InfluxDB2 on it, because the performance of CSI implementations is generally pretty good. The CNI implementations are good as well. The access policies, it's really, I'm not going to say easy because that's not really fair. There are really good support from all of these different projects to deploy safe and secure things on a Kubernetes cluster. And we will try and provide and make it easier to adopt as much of that as possible. Like, we do want to provide seccomp profiles for when you deploy it. We do want to provide, access policy, PSPs, pod disruption budgets, all of those cool things that we get for free, kind of, in a Kubernetes cluster that just allow us to make sure that the software is running healthily and as best as we can predict. So
cool. So folks, do you have any other questions for David that you can ask them now, or feel free to post them here, so I'll ask David to check back the live conversation, and he can answer that later as well, or reach him out on Twitter or the Influx Slack. He's super helpful, and I can assure you that he'll answer, because he will. So he'll help you out if you have any questions regarding today's demo or in general about Influx adoption and the comparison. He can give you out the links. So yeah, one request, David, I posted 2 links, one from your GitHub InfluxDB examples and one from GitLab. Apart from that, if any others are there, please post them to the chat, so that people can play around with it and they can spin up their own mini infrastructure and tag you. So I would suggest this: go ahead and use this particular setup that David just showed. Try out different examples, try out different templates, and tag us on Twitter, tag Influx Data on Twitter, what you have done, what you have learned, and we'll be really happy to see. And yeah, it will be really cool, because once you implement things, you'll learn more.
Okay, would you like me to show the logging?
Sure.
I don't know if I'm getting too confident now, but what I've done is I killed the kind cluster, and I've deployed a Minikube cluster. The reason I have to use Minikube for this part of the demo, and I should have thought of it earlier, so I'm sorry, is that we have to expose the Docker context locally, because I do need to build a custom image. Now that I've done that, I've built the image, I'm updating my new token inside of the fluentd values file. So we can deploy fluentd through Helm like everything else. We're using my custom built image and the same data for writing to InfluxDB. And if I do deploy fluentd, and we have a pod that's been running, second. Other image pool. That's annoying. So I think my Docker context doesn't live through this. So what I'm going to do is find my command here and just quickly run that again, which should run in Minikube context. It is. No, now it is. Okay. So that's now building in the cluster. So I guess what we can do is, if you want to move on to your presentation, and then if we have any time, this will take about 5 minutes to build, we can always come back to it later.
Yeah, I have a fairly small demos to show, so we can come back later to this once it finishes. And yeah, we can do that. Meanwhile, if there are a couple of questions that you can address on the chat, people are really asking for the links. So now you really have to give it the links to them. So you can hop onto the chat and paste the links.
Where's the chat? Sorry.
I'll give you the YouTube link.
Ah,
So
the YouTube chat. Right.
yeah,
Gotcha.
yeah. So that's going live right now. I'll just post you the link for that in Zoom so that you have that handy.
Come here. This link. All right. Don't play though.
Yeah.
Oh, the chat. Ah, there we go. There's the chat.
Yeah.
Got it.
So there are a few questions as well. So probably you can answer them live over there.
Okay, so let's first give you the BYO Telegraph example. We also want to share my Kubernetes example monitoring setup, which has a lot more stuff than we covered today. And we also want to share a community template. So, which are here. Okay, there you go. I think that's all the major links. If I've missed anything, that you can just tweet me and I'll get you those links as soon as I can. Questions? Yeah, so the ingress one, yeah, influxdb doesn't really mind what your ingress controller is. You can use whichever one you want. influxdb just exposes an HTTP API. So most things should just work. Is there an official influxdb Helm chart? Yes, I've been maintaining these charts for the last 4 months. The link is here. We keep them up to date almost daily, that we're making changes and adjustments. We're trying to make them better. We did adopt them from the stable repository. So there's a lot of history in the charts. Not all of the setup is something we would necessarily, as a company, promote as best practice, but we're trying our best to try and move them towards being more opinionated in the way that we would do it internally. Because, you know, we want to consume this stuff internally too. We don't want to say, here's stuff that everyone else can use, and then we do something completely different. So we're really keen to get those charts to a position where we're comfortable using them too. What else? Can you use customize a way of deployment? So do I have a customized example? Almost. On this Kubernetes example one, these are straight up manifests. These were built before the Helm chart for InfluxDB2. So you can kind of take these and use Customize to tweak them if you want. I'm a big fan of Customize. I do want us to kind of provide better tooling for using Customize. And there's also the job that does the authentication, creates the authentication for you. So those would be the starting points for using Customize to deploy InfluxDB2 to Kubernetes. And let me think about that. I'm sure we can provide something that's a bit nicer as well. Maybe in the InfluxDB repository itself, under a deploy folder, just providing JSON and Customize, I think might be actually really good, valuable additions for the community. So yeah, leave that with me. And did I miss any questions?
No, I think those are good enough.
Yeah. Okay. All right. So I'll just keep going then for another few minutes, if you don't mind. We have this image built now. So in theory, yeah, we have FluentD running, and we also have InfluxDB running. We don't really have any other workloads in the cluster, but let's see if we can log into the cluster and whether we have any log information. And if we do, I'll apply one more dashboard that is very much a work in progress. But something that I've got a lot of my focus on right now. So we're going to decode this password, copy this, and port forward again. Admin, password, we've got Explorer, we got the nada. Let's see what's not working. I might just have to restart FluentD with the updated token, because that pod is 5 minutes actually. let's just confirm so I don't waste too much time. Okay, it's just the bucket doesn't exist. So create telegraph. Let's see. Maybe it. Telegraph. Come on, computer. I'm not sure what the flush interval is on FluentD. $38. What time is it now? 39. Maybe there are just no logs. Let's deploy something that's going to be quite noisy. Let's deploy Nginx. We can always hit that a few times. This will work. I'm adamant. Okay. Okay, so we do have logs now. Perfect. We got some control. There's nothing wrong on this cluster, so the fact that the logs weren't showing up immediately just means I had to make a little bit of noise in the cluster. We can click on this. We can get the container ID. We can get the host, pod name, pod ID. We click go. We view the raw data, and we now have all of our logs. So this is actually the log lines. Now, because influxdb is a columnar store, we probably actually want to pivot this data so that we can view it in rows, very much like log data. Now, fortunately, I have been working on something like that. So let's do, I need my password, which is NF. Yep. Oh, no, I need my token, sorry. That one. And I'm just going to use packager again, only this time I'm going to apply something in a different directory. Where is it? Oh, no. It's right in front of me. We're going to apply Kubernetes fire.yaml. It's only, what, 3:30? It's been a long day. Okay, so there's my token. We also want to specify the organization. We want to do package, apply, specify a file, Kubernetes fire. Sorry, we don't need apply, we just need package. I'm going to say yes. Yes, there we go. Okay. Let's look here. So this is these are the Kubernetes dashboards that are shipped in the community templates. Now, of course, I appreciate the time that people put into them, but I found them to be actually rather superficial. They didn't go deep enough for what I wanted for a debugging experience. And that's what Kubernetes Fire is trying to provide. I want to provide a way that gives people the ability to really debug things when things are broken. Now, I know this dashboard looks broken, but this is actually just means health, right? It means healthy. I haven't configured it in a way that when things are healthy, you get big green ticks, but I guess I probably should. But what it wants to do is it shows us if there are pods waiting to be scheduled that cannot be scheduled. So let's make that true. So if we come back to this Nginx one, let's try and request 128 gig of RAM. And what we should see is we have this pending. This is now an unschedulable pod. And I don't have Telegraph running. Right, so what do I need? I need my tokens again. This is what I get for making this stuff up as I go. All right, so let's just quickly grab our Telegraph DS, paste in this token, Telegraph Kubernetes, paste in this token. Those will take approximately 10 seconds to get the data that we need for this to work. Okay. Now we do have log data, so let's take a look at that. Let's add a cell. And we're going to jump down to flux. So we're going to say from bucket telegraph range start, and we'll look at the last 5 minutes of logs. Let's do 15. And we'll hit go and view the raw data. Now, on computer. There we go. I really should stop using my laptop for these things. Okay, so as I said, the problem is this is columnar, right? So we actually want to be able to pivot this in a way that we can consume it. So what we're going to do is, how many tables do we have?
Can you zoom in a bit, David?
Yeah, I know this is going to be really difficult to see until we get it into the table view, but I will do my best.
Yeah, that's right.
Whoa. Yeah, we should be okay. All right, so let's flatten these tables. And let's pivot. Our column key is, we want to group by the container. So I don't think I'm going to be able to go. Oh, there we go, docker.container ID. So we're going to use that as our column. Oh no, sorry. Column key is field. Our row key is docker.container ID. And our value column is value. And that's an array. Let's see what happens. Oh, they're all arrays, right? I should have known better. Let's see if we can just speed that up as well. 5 minutes. Column key does not exist. It does exist. I typed it in. Let's try 15. Maybe I did break it. All right, what did I get wrong? Let's comment these back out, go back down to 5 minutes, look at the raw data, and someone tell me what I did wrong. Okay. Oh, it's under a field, right? Okay, so we need to get a little bit more complicated. So we're going to have to group by columns. Tricky. Let's use the fluentd tag. That'll be a lot easier. All right, I know this probably won't make sense just now, but I'm hoping I'll be able to explain myself if I ever get it working. Perfect. That's what we want. So we went from columnar data where everything was stored under underscore value and underscore field. We now have rows of data where the column names are the different components that we want to be able to filter on, inspect, and so forth. So now this is everything we know about a single log line. Okay. So if we visualize this as a table, we've obviously got quite a lot. So let's just filter this down on the things that we care about. So we probably don't really mind about the start and the stop window time. We don't mind about this. The image name may be useful. Let's avoid all the labels because they're too noisy. We definitely want to see the logs. The namespace ID we don't need, but we will want the namespace name. And for this example, we don't need about the host. We only have one. We don't need those labels. We don't need the pod ID. We do want the namespace name. I know there's a lot here. And let's take you off, you off, you off, and you off. All right. There's a lot of filtering, but what we have here now is the ability, and I'm going to have to zoom this back down just now. But we have the ability to view our log data next to our dashboard cells. Why do I not have metrics? Oh, there we go. Let's just do a big refresh in case it's just an anomaly. So I've got my deployment replicas unavailable 1, which affects 1 deployment. I don't have any waiting pods because it can't schedule them yet. Okay, so let's change the failure domain. And let's pop this down to be 500 MI. We want the pod to fail. So I'm going to inject a really crappy command because that's how I do things. And we'll say slept instead of sleep. 50,000. That means the pod itself is not going to be ready. We can then reapply our engine X. Let's see what's happening here. And we have container creating. Let's just give that another second. Okay. So if we refresh this. All right, let's see. What's the query? What have I done? Okay, so we're actually monitoring this. Yeah, the status code should be okay. There we go. I was too impatient. So now what we have is a different failure domain. So what we had previously was the pod could not be scheduled, and we got little markers here, and we had access to the logs here to understand why that couldn't be scheduled. Now we've got the pod scheduled, but the actual command is failing, and now we can actually see that it's one pod across one deployment that's being affected. And we have this chart that shows that it's currently unable to still schedule this. So as I come into this dashboard, I can see immediately something isn't scheduling. And I have the logs here. Now, we don't have a lot of logs coming from that. In fact, there are no logs coming from the Nginx container. Doesn't really help me. But we do have some of the other random containers running. So we would see the logs here, and we can just kind of look at those messages. Now, this is what I said at the start too. This is not the great experience that we want you to have when you use influxdb for logs. And this table component, we want to replace it with a log component, like we had in influxdb1 with chronograph. We want you to be able to filter on the different columns in a very nice, simple fashion. We want to be able to select a time window here and have these logs filter to that time window. And I am really driving and pushing for that functionality to be in sooner rather than later. So what I've shown you is you can collect the logs. It's not a great experience, but I promise you it will be better soon. Phew, I got it working.
Yeah, I mean, that's really great. I mean, it's really nice to have a few of the things. And like you said, the future, you see the waiting pods and you see the reason below from the logs. I mean, that would so be good for the person who is debugging something and can immediately see from the UI what's wrong with the cluster without going into the cluster. So that's what the whole experience will be really good, I feel.
Yeah, I think just a little bit more time, get those missing components in that we need, and then, making sure that we have the community template available that gives you this new dashboard and also has the alerts pre-configured. And once we have that, I'll feel a lot more comfortable, really encouraging people to adopt influxdb in their Kubernetes environment. So right now it's for the people that are willing to put in a little bit of work, really get to learn Flux and navigate those little bit of uncomfortable waters, but the reward is definitely there. It's great.
Yes. Yes. And we have one very good question, like what's the best way you suggest to pass the secrets to different YAML files?
So all of our charts do support just consuming secrets as files or environment variables. So what we generally expect people to do is to deploy the secrets to their cluster using Bitnami's sealed secrets, or using Mozilla SOPs, using, there's a Vault, whatever you want to use for your secrets management is to use that. And then all of the charts do have hooks where you can say, expose this secret as this file, or this secret as this environment variable. Telegraph can consume them, InfluxDB can consume them, It should mostly be plug and play. So we try to be really unopinionated on how you manage your secrets and just make sure that we support secrets as something that can be configured. So I hope that helps.
Yes. Okay, I think there's no other questions at the moment. If you still have any questions, please feel free to ask, or ask David on Twitter. He'll be happy to help. So is there anything else, David, that you want to show in final words? You want to conclude?
I could keep showing you stuff for the next 6 hours if you want. I mean, but I think there's been a lot here. Hopefully, I guess just to summarize where I think we are in our Kubernetes monitoring journey from an influx perspective is that using the Helm charts to get bootstrapped, have influxdb inside your cluster, deploying Telegraph using the 3 different options are all equally important. Find the one that you want to use, adopt it, and then continually improve that. BYOT is there if you want to deploy Telegraph to edge locations or maybe places where just bandwidth is really important. Memory is constrained, CPU is constrained. That's going to get you a lot more value and bang for your buck. And stay tuned. Like this Kubernetes Fire dashboard, like I said, is my primary focus right now. Like within the next 10 days, I will have this dashboard built out completely with logs, alerting everything for a Kubernetes kind of stand up and run experience. So keep an eye on the community templates, keep an eye on my Twitter. There's lots more to come in the next 10 days.
Awesome. That was really great learning. I mean, I myself learned a lot of stuff about Kubernetes monitoring and how things are working internally and how you can use and leverage Influx 2.0. I think beta 13 is out right now. Am I right?
Beta 13 dropped yesterday. Yeah, it's fresh off the presses. There's a couple of really good enhancements to it. Performance is also massively better. Our team is currently focusing on performance on InfluxDB 2 and has been for the last kind of 3-4 weeks, will be for the next 6 weeks. Like we're now just trying to get as much out of a single machine as we can, and then we'll start looking at what comes next.
Awesome. So go ahead, folks, and try to use whatever was mentioned in today's session, and do tag out Influx and David so that they know, like they have spent so much time and you have learned something and you try to make something. And if things break, yes, then also give a shout and we'll be happy to help you.
Definitely.
Thank you for your time, David.
No, my pleasure. Thank you for having me. It was great to be here.
Thank you so much. So I'll share my screen now.
Good, I can shut down that cluster because I think my laptop was about to take off.
Yeah. So yes, I didn't. I was not expecting the stream to be so long because it's Friday. I don't want to consume all of it. But the session was so interesting that even if it would have gone to 2 hours, I wouldn't have stopped because things were really getting interesting, and I learned a lot of things. And I am sure that you people also learned a lot of stuff, a lot of good questions that came out. So thank you for that. What I have for you is I don't have the slides or anything like that, but what I have here is I wanted to talk about Kubernetes, extending Kubernetes with Go. It's one thing that everyone wants to do, and it's one thing that Kubernetes provides, which is very good functionality. So Kubernetes on the whole is a very big platform that has its native components and native functionality. On top of that, it provides the organizations and the users and the community the flexibility to extend it without touching the code base of the Kubernetes itself. So if you want to have any additional functionality over the API server, over the controller manager, you can build on your own, and you can keep that in your own repository. You don't even have to touch base any of the existing Kubernetes code, which is actually excellent. That's what makes Kubernetes more robust platform because of the extensibility. And you have seen all the operators, all the CRDs, the custom resource definitions that the big organizations have built up over time. That shows that how people are leveraging Kubernetes and building stuff on top of it. and you can actually see organizations built on top of it. So people actually are creating products, and they are making their own startups out of it, just on building on top of Kubernetes. So that's much flexibility that it gives. So on the whole, yes, Kubernetes itself is a very good ecosystem that you can as it is, deploy and work. But there are some things which you actually want to do, some things you want to extend, like you want to have your custom watcher that does some specific functionality for you. So you can go ahead and you can use the client SDKs. So it's not only limited to Go, first thing. There are other languages that you can develop it, Java, using Python. So but the most regularly update, which gets the immediate update of the latest new feature that gets updated to Kubernetes itself, all the APIs and everything, they gets immediately updated to the Go client library. Reason, but obvious reason, because Kubernetes itself is written in Go. So that's why you would prefer to have a Go client and consume that, and you will be able to have all your functionality, all your new features that are running without even touching the code base. So you don't have to understand the massive code base of Kubernetes. You don't have to do anything of that. You just have to understand how, as simple as you write your own REST APIs. So just use the client Go. It has a lot of extensive libraries, the packages that you can do. I'll just show you all the things. So this is what we'll be demoing today, but there are other packages. Let me just go to, yeah, Kubernetes API machinery. We have the API machinery that helps you create the APIs, and that's not only for the Kubernetes ecosystem. You can use the API machinery to create APIs of any sort, not only for the containerized environment, to be specific. So this is the API machinery. So you can create Kubernetes API type objects. So there are two parts of it. You can use native Kubernetes objects like pods, deployments, daemon sets, etc., and and directly query them and write your own functionality on it. And if you do not want that, and you want a custom resource, so that's where CRDs come in. So you write your own custom resource only. So that will be like, you do kubectl get pods, you can do a kubectl get your own resource name. You can create that if you want completely different resource that Kubernetes should be able to understand. So for that, you will be writing a CRD, and that's also something that you can do very easily with the tools that have been provided by Kubernetes and the community that is driving it. So what we are focusing today is the Go client library. So we'll go to Kubernetes client Go on GitHub. I want to show you a few stuff over there. So it has all the verbs, all the verbs that are there. You can have a create, get, list, whatever things are there. There's a special verb also, watch, that most of the folks would be interested in using. You need to watch something, and on top of it, you want to implement your own stuff. So that's where things get interesting, and you can do something. So if you go to the tools, you have watch, and you have other things. So this is where the Kubernetes is there. And so you have, so these are something discovery. So this has its own package functionality. So you have informers. So there was one blog which I was reading, which has very good explanation about the informers that you can use. So what we are going to show you today, what I'm going to show you today is not this tab. Which directory? Okay, so that's a very simple file to get the list of pods that are running in your Kubernetes cluster. So what happens is it's a Go file. So what you do is you have your import, and we have some of the imports that we'll be using for writing the code, and these are some of the imports that are required for Kubernetes itself. So in clients Go tools, there is client CMD, and you can see in client Go tools there should be a client CMD that helps you. So this is basically that helps you get connected with the cluster. So you will be having your configs, the configs and everything that helps you load it. So let's see the main thing. So we just first thing to interact with the cluster is obviously the kube config file. So once you have the access to the kube config file and you make the client, so what we are trying to do is we are trying to create a client by providing the kube configuration. So once you have the access to kube config file, you know that anywhere you can just have the kube config and you can run kubectl hyphen kube config, give that kube config name, get pods, and things will work. So behind the scenes, what happens is it actually interacts with your API server and gets the list of, in the end, it interacts with the REST APIs of the API server and gets you back the results. But what here we are doing is we are trying to create a client, and before creating a client, we need to have the configuration with us. So for that, we have a kube config variable, and we give the file path of my home. So generally the kube config file is in your home directory .kube folder. So from there itself, this particular thing is joined, and then it's just a print statement. And now here we are building our client. So we are using the same that I told you, client cmd, to build your client, and we are building from the kube config file that we have declared over here from our home path .kube folder. Now let's go below. This is just creating a REST client and not triggering the specific API. So now we have the client set ready. So we say we have a new configuration and we are passing the config of the client CMD that we just built. So, but this won't call any of the API. And now we try to get, now we are trying to actually call one of the APIs, and the pods are in the core v1 API. So what we here do is we go to the client set, whatever we have defined here. So this is the client that we have created. So our client is ready now. So for here, the config is ready. Here, the client is ready. Now what we are trying to do is from that client, we are trying to hit the API that returns a list of pods. So this particular thing is client and the core v1, and from there we are trying to get the pods, and we are trying to list them using the list verb, and we'll get all the pods over there. This is just an error check. Now from the pods, we are going to iterate it, just a simple iteration, and we are going to print the name of them. So as of now, I'm running the Docker Kubernetes cluster, so which is just the Docker desktop that just install Docker, and you can run Kubernetes that, or you can use Kind that David showed, or you can use Minikube, whatever you want to use. You just set the context properly in the kube config file so that your current context is set over there. And we'll try to run this file and see what happens. I forgot the file name itself. Okay, main.go. So it should print all the list of the pods that are running in the cluster. Hopefully it does. Yes, so I have a couple of pods. I mean, not couple of pods. I have some pods that are running in the cluster. So you can see in all namespaces. So we have Prometheus, we have, these are the normal pods that are required to run Kubernetes itself. We have API control manager. So this is just the name of the pods that are running in the cluster. So as simple as that, you have got the list of pods. Now what you can do on top of it, you can get the list of unready pods, or maybe you know that if this particular pod comes up and it's one of the check fails, and on some of the error, if you restart it, it works. So you can have that sort of functionality on top of it. So you can just get the pod name and do a restart of that, and your things will be fine. So this goes as an automated behavior rather than me going in and performing some action using the kubectl command. So that's just the basic examples. Definitely you can do a lot more with that. Now, another example that I want to show you is of the watcher. So Kubernetes watcher is a very good that the client Go provides. So there's one example built by this person. So he's a software engineer VMware. So I found this very cool for the example. So there are a lot of examples that you can go through. So it's a PVC watch. So PVC is a persistent volume claim. So those of you don't know, so it's just a persistent volume and persistent volume claim, and then you create a pod that uses a persistent volume claim. So I have the basic setup ready. I have just one from, if you see from this particular example. So I've just, as it is, followed this example. You don't have to do anything. It will create a persistent volume. It will create a persistent volume claim. It will also create a pod that uses a persistent volume. So you can see over here, you create a persistent volume, give some capacity with the access mode and the path. Make sure your path is same or whatever you have given. Only this particular portion, I feel you have to change. After that, you create your persistent volume claim. After that, you create your pod with that is using the persistent volume claim. That's it. That your setup for viewing the persistent volume claim, the watcher, will be good. Now let's come back to the code and see what all is happening. We'll not go through a lot of it, but yes, and which folder it is, demo 2, I feel. Okay, not this one. Yeah. So again, a Go file is there, and yeah. By the way, there are two things. There is a good way you have to get all the APIs, that all the imports that are there. So you have to do a Go get of that particular API. Sorry, of that particular module that you have to use inside your Go. So you have to do a Go get. I mean, you can do a dep also, which is dependency, which downloads all the dependencies required, or you can do Go get of the individual module, or you can do a go init, a go mod init, and it will create a go mod file. And you can, if I show you, so it requires, so you can type all the things over here, and then you can, then that also should work fine. Else your code won't run. It will say that it do not have certain and certain dependencies for that. So that's pretty much it. Let's see, what do we have in pwd. Yes, demo2.go. Oops. So it's not that complicated, and so you can see these are some of the things that we need to use. These are some of the things from the Kubernetes. From that, we have to do a go get of this with respect to a specific version. There can be a version incompatibility, so please do check the compatibility of different versions before using them. Again, the first piece is getting the kubeconfig file from the variable, and then you have your, it's the bootstrapping, the client creation. Then this is the initial list. So initial list of the persistent volume claim with respect to the label selectors. So again, so what we are doing is we are trying to call the APIs. So now we are calling the persistent volume claim API. So things like that will be used. So you can see client set, again, core v1 persistent volume claim, and we'll do use a watch. So earlier we used the verb list. Now we are using the verb watch. So that's what I told in the beginning. There is a special verb which is watch that you can use using the client Go. So then we get the result of the watcher, and this is something that we are just printing out and giving, like it is over budget or within the field, what is the maximum claimed volume and all that stuff. That is not that much required. Let's see this in action. So you can see all the print statements that were there that we didn't discuss. So you can see that I have on today itself, I created one PV claim, which is the persistent volume claim, named is the task PV claim. It is same as this. You can see over here, task PV claim. So I used exact repository, exact thing that is mentioned in the documentation, Kubernetes documentation, and that particular name appeared here, and the claim size is 3 gigs, and it tells you the percentage of the claim capacity. So like this you can implement. So this is just a demo example, like of what exactly it is, how you can use the client library. The extensions of it is vast. I mean, it's really huge. Like I told you earlier, people have created their own organizations by building on top of Kubernetes. So you can build a lot of cool stuff on Kubernetes, and Golang itself is a very good language to learn. If you are new, definitely go for it. We have Gopher Labs that we started. I mean, Sangam is there inside in the chat itself, in the YouTube chat, so you can ask him. So we have Gopher Labs, we have Cube Daily, so that gives you free to learn tools for learning Go language. and soon we'll be doing a live 4 or 5 hour session of learning Go, so that you are well versed with that. So once you have that set of knowledge, yes, I would suggest you to have a certain thought process in mind, a certain project in mind, like what all you want to do with Kubernetes, because you have a client Go, and there is a wonderful opportunity that you can create a small product, or even a very small contribution that you feel is very important and very required by you. So you can create that and contribute to the community. You never know, it might be merged into the original original repo, or it might be hugely adopted by the community. So that's how the crew came in. So people started building, Kubernetes plugins, kubectl plugins, and then crew came in. So all those things, the extensibility of client Go is vast, and it's infinite actually. So just like we have infinite series, so it's infinite to have this, and you can build a lot of stuff using Go. So you have Kubernetes client Go, you have API machinery. So all those are very cool projects inside the Kubernetes, this repository. So if you see Kubernetes itself, it has a lot of repositories under it, and you should have, you should go through few of them, at least client Go, the API machinery. So these are some of the things that you should actually go through to see the in-depth things, what is happening in the cluster. And moreover, the API interaction is what the developer is interested in, because they are the REST API, they want to consume it, they want to write new stuff. So that's what actually makes the developer life easy. It will help you use the existing APIs, create on top of it, or create a completely new API and contribute towards it. So a lot of things are there. So I didn't have much. I didn't prepare much of the things like David had for you today. Much cooler demos. But I wanted to show you. Yes, this is the basic examples that you actually can go home and try it out yourself right now. And just you have to set the Go path. Just you have to have Go installed and have the right dependencies using Go Get. As I mentioned before, and you should be good to go with at least start doing get pods, get list, then start doing a watch on that, and then maybe do some cool stuff. Maybe delete one if the replicas are more. Maybe restart if one is in crash loop back off, something like that. You just do, and just tweet out like you tried this and this is cool, and then we can extend it. And yes, definitely programming Kubernetes. There are a lot of books around it. Programming Kubernetes that you can read, and building cloud native using Go. So all these things are there that helps you, getting started and building cool stuff. So that's how a small project starts. So you can start itself, and you can start yourself, and it might turn out to be a big organization. You never know the adaptability by the community. So that's what I had for you today. If you have any questions, definitely ask me. I think Sangam is very active in answering all the questions live. So if not, I'll answer them. So before going, what we'll do is we'll do a quick giveaway, and I see a lot of people are there. So how do we do a giveaway? Suman has already won, so Suman won't get the giveaway, and the moderators won't get. So without then, okay, let's see who asked most questions. Harshit has 1, 2, 3, 4, 5. Preeti has 3, 6. Okay, so I think Harshit was the one who has been there with us with the stream, and he has asked a lot of questions as well. So I would give today's voucher to Harshit, and okay, Nitin is also there. Then probably I leave it to David. David, you can select out of Harshit and Nitin who can get the today's swag winner. So you can randomly pick one name, and I will just give it away. That's it.
Do you want me to pick one name from the YouTube chat?
Yeah, just pick one name who's not the moderator and not Suman. Because Suman last time Suman won.
All right. Nathan Thomas.
Okay, so Nathan Thomas, you are the winner of today. So please give a shout out to CNCF for this particular giveaway, and just DM me. I'll give you the voucher code for that. So thank you everyone for joining today's stream. Thank you, David, for spending your Friday with us and helping. I mean, showing us very cool demos and very cool stuff that Influx is targeting on, which is very interesting. And I feel the community would be interested a lot. So one suggestion to everybody: just go out and try it out. Whatever David has shown, it's really interesting. I will try it out and try the Go client library. Sorry, the Kubernetes Go client library as well, and we'll meet sometime later as well. Okay, thank you all. I'll be closing the stream.